Welcome back to the study where I said I do trig all the time. You can see that. You see there's a guitar back there. The guitar strings vibrate. That's described by trig functions. So that's a period of 440 hertz. The frequency is 440 hertz. See, there's a map up there of Sydney Harbor. This map was done around 1900, and the way it was calculated where everything goes was using trigonometry. So when I say I do trigonometry in here, I'm not joking. So anyway, let's get back to the law of cosines. And what we had to start with was a couple of lengths, A and B, and an angle between them. And it didn't matter which way we were going to measure that angle because we're going to take the cosine. And let's actually extend these just so they're a little bit more interesting to look at. Okay, so we got some lengths. Now there's a triangle there. You have to fill it in, and that triangle is here, and we'll call this side C for no particular reason. And the way that we get at the law of cosines is one of my favorite ways of doing mathematics. It's really one of the few ways of doing mathematics is to do as follows. I'm going to take from the corner up here where the side of length A meets the side of length C, and I'm going to do what they used to call drop a perpendicular. In this case, it was actually vertical, so I dropped it. And so that's going to be perpendicular to B. You're always going to be able to do that. And that green segment has length h. And the first and most important thing that you can notice is that that segment is part of two different right triangles. One is the one on the left that includes the angle theta, and the other is the one on the right, and you can see that they're right triangles. And so that's going to give us a way to find a formula because we can express h two different ways. So one way to do that is to, well, they're all going to be looking at the bottom side of this, is the bottom side here is length, the cosine of theta, let's write this out. The cosine of theta, I'm sorry, the sine of theta is h over a. And so this middle side has length a times the cosine of theta. Now the whole bottom here has length b, and we've taken a certain amount off, so we'll just take that off. This is b minus a times the cosine of theta. So those are the two right triangles that are involved, and we can write h, or well, let's be smart and write h squared two different ways. One way is using the triangle on the left, and we know that the quantity a cosine theta squared plus h squared is a squared. That's Pythagoras. He's bound to show up sometime around this time of day. And on the other side, the same kind of Pythagoras thing says that h squared plus, and now it's something more complicated, squared in the parentheses, we'll come back to that, is equal to c squared. C is the hypotenuse of that triangle. And you have in the parentheses b minus a cosine theta. All right, well now we get to do some algebra. On the left, h squared is a squared minus, I'll just multiply that out, a squared cosine squared theta. And on the right, h squared is c squared minus that monster thing in parentheses, b minus a cosine theta squared. And we'll just set those equal and plug and chug. So let's get a more interesting color for that. And so what we have here, a squared minus a squared cosine squared theta is equal to c squared, and now I'm going to do the parentheses first, but I'm going to multiply out that square there, so that is b squared minus 2ab cosine theta plus a squared cosine squared theta. Plan ahead, guy. Okay. Well, that doesn't matter because each side has a minus a squared cosine squared theta. Those go away. And what we're left with is that a squared is equal to c squared minus b squared plus 2ab times the cosine of theta, or c squared, bringing that over, we'll bring everything over to the left, is a squared plus b squared minus 2ab cosine theta. That's the law of cosines.